Hello, welcome to lecture Automatic Identification and Data Capture. And today, the main topics are going to have a little bit of overview of what this technology is, and also talk a little bit about the barcode and also RFID, as well as some other technologies related to AIDC. All right, so automatic identification and data capture. This is actually a group of technologies or practices that are taken in production companies to capture the data from the manufacturing processes and then store the data into a computer or database so it can be processed by the computer program and then for decision making. And so the reason we're using automatic function instead of human counting or data collection is because there are several problems related to the manual collection and data entry. First, it tends to have higher errors with human counting, because human labor can be easily distracted by some other things, and also the error rate a little bit high, and also time factor. So it also takes time for human operators to collect the data and then enter the data into the computer program or database. So there's a time delay. Also, there's a labor cost for that. So implementing an automatic identification method, practices, or technologies actually can save money and also increase the accuracy of data entry, and also reduce the time that is needed for entering into the database. For the applications, actually it's not only just in manufacturing but also in a lot of other places. For example, in retail sales, inventory control, material handling, shipping, receiving. Basically it's everywhere that requires data collection. For example, if you go to the Walmart or Costco, you can see people are using a barcode, right? Using a scanner to scan the barcode, and then it automatically going to generate the information for of the item. It's the same in production. So with different batch of either parts or products, then you have to identify what kind of parts is that, do we have enough parts, and what is current inventory of those. And it all can be collected by IDC technologies. First, let's look at what are the key components of this technology. The first one is the data encoding. So data encoding means we are converting the alphanumeric characters, either text or numbers, or maybe images or some of the information that can be translated into a machine readable form. So machine readable form, it can be some of the data that will eventually be converted to electrical signal. Then the electrical signal will be converted to digital data, right, by using data decoding. So that we discussed it before in prior lectures. So this is how it converts the alphanumeric characters to the digital data. And in terms of different technologies, we have optical ones. For example, using the barcode and QR code, and it has been widely used. And also there are some electromagnetic technologies that can be used. For example, radio frequency identification, RFID, in other words, is also a very common technology. Another one would be the magnetic, for example, stripes, right, or tapes. Think about when you are using our credit card. So we also have the little chips, so you can slide and pay. And also there are some of the smart cards, some plastic cards, and also has the microchips in it. And some touch screen is another technology, and also now people are recently there are more there's a kind of trend for using biometric technologies in data reading. For example, unlock your phone, right? You can use your fingerprint, you can use voice to recognize it, and also you can scan your eyes, right? So that's all can be used in data capturing. And how to measure the accuracy of IDC technologies? A couple of things. One is the first read rate. So first read rate means when you scan something, what is the probability of being successful at the first time, right? At the initial attempt, right? Sometimes you especially in the prior years, you might have seen that people have to scan it several times until it can be read, right? So if technology is well developed, and the first read rate should be high, which means you scan it immediately, you will get a result. So that's the first read rate. And the second one is substitution error rate. So substitution error rate means it's the probability of scanner incorrectly reading the encoded character as some other character. So means it's it is reading wrong information. Right? It is reading wrong information. So that's substitution error rate. In order to calculate how many number of errors, you can just use the error rate times how many times how many characters actually you read in a scan. So that's a couple of rates that you can use to measure the technology's accuracy. And different types of the barcode. So barcode is a very common one. Different types of barcode. One barcode is the linear one. The other one is the two-dimensional one. So the linear barcode you can see from the first the upper example. It's we're using linear suite of the scanners that you can scan the lines, right? You can see that. So really it's the width, right? It's a width. And also the color, white and black, that defines the difference of the of the linear barcode. Well, another one is a two-dimensional one. So two-dimensional one can tell basically are using some of the squares, at different places, and in a shape to read, to contain information. Linear barcodes. Couple of different linear barcodes. One is the width modulated. Width modulated, as we just saw before, we can use different widths of the lines to code the information, and it has been used a lot in universal product code. So universal product code, you can see that commonly in some of the products, either in supermarkets. You can see there's at the back of the package, you can see there is the barcode. So they all have been identified as a certain code. Another one is the height modulated. So height modulated means we're using different heights of the bars, right, to contain the information, to code the information. And USPS has been widely used. You can see the upper information that is the width modulated barcode, and the lower part that is height modulated barcode. There is a video, so we can take a look at how this barcode works, and how it has been used in our lives.
This video was made possible by Squarespace. Build your website for 10% off over at squarespace.com/HAI. So, when you stop in a store and scan a soda, the beeper beams lasers and the barcode becomes numbers. This thing, though, isn't free, no, because of these guys. But enough of that poetry, poppycock. This is the headquarters of the GS1 organization, which basically runs the world's barcodes. They've created and maintain a common standard of barcode that works anywhere. No matter if you scan a product at a Tesco in Thurso or a Coles in Canberra, the machine will recognize what it means thanks to this organization. But here's how it works. A normal barcode has 95 bars that are either black or white. The first 3 always look like this, the middle 3 always look like this, and the last 3 always look like this. That's to differentiate the different sections. The remaining 84 bars are split into groupings of 7 in order to make 12 sections. Each grouping of 7 correspond to a number. For example, this means 0, this means 1, this means 2, 3, 4, 5, 6, 7, 8, and 9. Unless they're on the right side, because simplicity sucks. For the groupings of 7 on the right, this means 1, this means 2, 3, 4, 5, 6, 7, 8, and 9. Got it? Good. Because the main difference between the codes for numbers on the left and the codes for numbers on the right is the number of white bars. For example, the code for 6 on the left has 2 white spaces, while the code for 6 on the right has 5 white spaces. For 9, it's 4 on the left and 3 on the right. You might see a pattern. All the codes for numbers on the left have even numbers of white spaces. All the codes for numbers on the right have odd numbers of white spaces. This is so if the code is upside down, the scanner knows to read the code from the opposite direction. If it sees the codes with odd numbers of white spaces on the left, the machine knows to start reading from the right. But before being able to make barcodes, you need a company prefix, because the first bit of any barcode is devoted to identifying the company that makes the product, and then the first 3 digits of that identify the country where that company is from. For example, this cream cheese, which was one of 5 things in my fridge, starts with country code 622, which corresponds to Switzerland, where the European headquarters of the manufacturer, Mondelez International, is. Each country worldwide has its own code. But don't worry, America, you're still number 1. But also 2 through 19, 30 through 39, and 60 through 139 because big countries need lots of codes to allow for lots of companies. After the country code comes the company code, but the number of digits varies. Basically, whatever space that isn't filled by the company prefix, with the exception of the 12th digit, can be used for product codes. So, the GS1 organization prices the company codes based off their length. You can buy a 10-digit company prefix, which includes the country code, for only $250 since there are 10 million of them for each country code. But then you would only have 1 free digit left, so you could only have 10 different products. Therefore, if you're a much bigger company, you want to have a much shorter prefix. So, GS1 sells company prefixes as short as 6 digits, but they cost $10,500 since there are only 1,000 of them out there for each country code. With a 6-digit company prefix, you can have as many as 100,000 different products. The product codes, living here between the company prefix and the 12th digit, don't really have a common standard, so each company can set their own codes. They all go into a central database, so any store worldwide selling this cream cheese, for example, can know the code. But then there's this 12th digit. This is there to make sure that the scanner read the rest of the digits correctly. It's called the check digit. What you do to calculate the check digit is to add the numbers from all the odd number positions, multiply by 3, add the even number digits, and then subtract that number from the nearest multiple of 10. Easy, right? At least if you're a machine. If the result equals the final number, the machine knows that it read the barcode correctly. Although, if you're not a machine, what might not be easy is building a website, unless you use Squarespace. With Squarespace, you can make a website.
Alright, so that's about the universal product code. Next, so one common code you might want to remember is SOS, right? Signal code, which is the Morse barcode. And the SOS code is very simple. It's 3 short signals, 3 long signals, and then 3 short signals. So it can be in any kind of form. For example, some D, 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 D. It can be SOS, or it can be using some flashlights. Right? They all can be used as SOS. For example, we can use this example. See the 3 short ones, and then 3 long ones, and then another 3 short ones. Let's listen again. Okay. Well, if we use another form, it's a flashlight. All right. So this is just one common SOS code you had. It's better to remember in case in some applications that you might use it or see someone or see some of the signals that from others. All right. So how to read the barcode? So the barcode. So the one is you can sweep use the light beam to sweep the light beam to scan it. And then the code or the width of the bars, it can actually be converted into electrical signal, so you can tell if from the signals high and low to read the information. And some widely used linear barcodes are, CODA barcode. So usually, that's has been used in the libraries, or some blood banks, or some parcel freight applications. UPC mainly that's for grocery and retail stores for products. Also, in Code 1939, that is often used in the Department of Defense, automotive, and also some other manufacturing companies. So like the one you can see here, F002736, something like that. The post office, they like to use the height, the bars with low, high and lows, as at their barcode. And the readers of the barcode, linear barcode, we can use contact ones and also some non-contact ones. For the contact ones, basically you can use the wands or light pens, right? By moving the tip across the barcode, and they will read the information. Well, the non-contact one basically is it just uses the light beam that goes through the barcode and scan the barcode. And for the light beam, couple form of the light beam. One is a fixed one, the other one is a moving one. For the fixed one, so basically the beam is there and is fixed, it's not moving at all. And what is moving is actually the code is moving, right? Because the code is on the product. When the product moves, it can actually read the code. So that's the fixed beam. Another one is the moving beam. The moving beam will mean the beam itself will move up and down or left and right. So all you need to do is just keep the product there, right? So sometimes there also be some of the moving products, and as long as you can have the moving beam scan all the all the bars, then it can actually read. For example, in this case, you can see there's a scanner sitting there, and then there's the moving beam. Moving beam is actually going up and down to scan all the codes from the product. So this is a stationary moving beam barcode scanner. Another type of barcode technology is a two-dimensional barcodes. So two-dimensional barcodes means from the prior example, all we can is just some of the bars, right? So that is the 1D. So now this is the 2D barcode. For the 2D barcode, a couple of types. One is the stacked barcodes. So stacked barcodes means basically that's we're using conventional barcodes from the 1D ones, which is those bars up and down, and then just stack them together to become the 2D dimension. Or another one is a matrix symbols. For example, some patterns or some squares here and there, commonly see in the QR code. So two different ones. So the 2D stacked barcode, as you can tell, from the upper image. So that's a stacked barcode, and for each row, actually you can see the traditional or conventional barcodes, 1D barcodes. Then they just add one row on top of another to become a 2D stack barcode. Well, the second one is the matrix barcode. As you can tell, it uses the matrix, with different squares and also empty white places to contain the information, to code the information. So that's about the barcode. And next technology is radio frequency identification, or in other words, it's called RFID. So RFID is a very actually commonly used application in technology in many applications. And for example, in hotels, right? Your door key, that will be the RFID, and also a bunch of other places for scanning your to get in the door, security, all of those. And so how RFID works? So there's the tag. The tag consists of memory microchip, and also an antenna, usually encased in a plastic container. So the tag is actually a transponder, and so it can emit a signal, and then it receives the signal from it can also receive a signal from another external source. So what happens is the tag is gonna communicate with encoded data using radio frequency, and it passes the reader. And then also it is activated by a low level radio frequency magnetic field transmitted from the reader. So that's how it communicates, as you can tell from the image. So RFID reader actually emits a signal, and then the tag on the RFID tag on the object will actually receive that. So this is how it communicates. And readers, there are different ways of reading the RFID. One is you can use a handgun to read it. Another one is we commonly see in the security gates, right? We can also use that to read. Now let's look at some examples.
Hi, I'm Susan Flake, RFID Business Development Director for Zebra Technologies, and I'm here to introduce the RFD 8500. It comes in under a pound. It's multimodal, offering both scanning and RFID. And did I tell you, it's fast. Amazing. I just captured 536 pairs of jeans. Zebra's RFD 8500. Visibility, that's visionary.
So this is using a handgun to read it, handheld reader. Another one is a gate reader. Okay, so this is a gate reader. All right, so there are different RFID tags. So mainly there are two types. One is passive tags, and also another one is active tags. So passive tag means there's no internal power source. So basically they just get their electrical power from the external signal from the reader. and those tags are simply small and less expensive, and also it can last for a long time. Another tag you might see is that they are active tags. Active tag means they actually have their own battery power pack, and also have a larger memory and a capacity. So the benefit of this is it can be read in a long distance, and also the information on that it can be actually be erased and be rewritten. So that's a advantage of it. But the problem with active tags are they are very expensive, and also usually they are being used for higher value items.
In this video, we compare active and passive RFID technology in various application examples. In access control applications, passive tag users have to tap their tag against the reader for reading. But for active tag users, all they need to do is to carry their tag with them in their bag. Active tags can be read by active readers at a long distance, and the performance is not affected by water or metal. In customer relationship management, passive tag users have to present their tag to the staff for verification. The staff will not be able to greet and serve customers right away. But for active tag users, their tags are being read before they reach the entrance. Staff will be able to view information of the coming customers before they reach the reception. The staff can greet them accordingly right away, which will be more impressive. Passive tags are not durable and can be destroyed easily. A simple scissors cut would damage the tag completely. But for active tags with robust plastic casing, they won't be damaged even if a car runs over them. With battery inside, active tags can achieve a much longer reading distance. By constantly sending the tag ID to the reader, active tags can facilitate different tracking applications. For passive tags which does not have power source inside, no tracking applications can be achieved, as the reading distance is shorter and the tag can only be read when someone taps it against the reader. Active tags can be equipped with a digital sensor which can be applied in environment monitoring applications, but passive tags do not accommodate sensors to perform such sensing function. Hope the video gives you an idea on the difference between active and passive RFID technology. For more help on choosing the right technology and products for your application, contact us at sales@hongkongrfid.com. Thank you.
All right, so that's about RFID tags. And for the industrial applications, there are many different applications for RFID. We can look at some examples. Inventory management.
RFID makes it possible to quickly extend data collection and controls to locations, users, items, and events where it was previously not feasible. This is due to three characteristics of RFID that were previously unavailable. When using RFID tags, it is not necessary to be able to see the tag to read the information on the tag. The tag can be in a box, under packaging, or between parts of the actual product. The RFID reader can still find the tag and retrieve the desired information as long as it's not obscured by metal or liquid. In addition to each of the same product having a similar identification, which a barcode provides, each tag has its own unique number. Now you can list certain characteristics of each product, as well as its entire cycle history if desired. This makes it easy to determine duplicate items and sort them from oldest to newest. Scanning with RFID requires less training, less preparation, and has a much higher capture rate than other methods. This allows for visibility, data capture, automation of inventory, and procedures that were previously not practical. Our team has been implementing and perfecting item-level RFID applications in the field.
It can also be used in supply chain management. So it carries the information with different stakeholders along the whole supply chain. Another example in the tracking system.
Tracking the attendance of your workforce is critical to a contracting organization. Any deficiency in the tracking systems will result in significant losses to the organization in the form of low productivity, penalties, fines, and revenue losses. Current systems are mostly manual, spreadsheet-based, and sometimes inefficient. It would track the workforce only at the entry and the exit. But between the entry and the exit, some of the workers may have jumped the fence to go to a different site, taken extra long breaks, or just roamed around the site. Even missed punches or incorrect entries will be treated as absent. To address this problem, we have two solutions. RFID-based tracking. A unique RFID tag is fixed to the worker's ID card or their uniforms, camouflaged on the collar or behind the logo in the chest area. The RFID reader fixed at the client site or carried by the supervisor will keep track of their attendance. Any miss or mischief is immediately noticed, and their attendance is updated to the central database through mobile connectivity on the reader. This data is now available via cloud to anyone who needs it. GPS-based tracking. The same system can also be implemented with a GPS tag instead of RFID. which will allow tracking of the exact location of the worker using the GPS satellite tracking. Apart from live workforce movement tracking on a cloud application, it can also help send SMS alerts for pickup and drop. RFID or GPS-based tracking provides an efficient and technology-based management of your workforce.
All right, so another example, of course, can be used in warehouse control and also location identification. Another example is work in progress. We can take a look.
You know that in your business, information is power. Being able to track your assets effectively, reducing the time you hold on to stock, and monitoring the flow of work in progress can save capital and improve delivered quality. But sometimes capturing the right information at the right time is expensive. It can take too long to get the data you need, and it can be difficult to make use of it when it counts. That's where RFID technology can help you. These are RFID tags. They come in many shapes and sizes, but they all do the same job. They tell you what things are. Readers like these interact with the tags to collect information, like where things are. So you can track individual components on the assembly line, individual steps in the production process, testing and quality control, completed goods, pallets of products, and even items sold and later returned under warranty. This technology is used in manufacturing, logistics, service, and maintenance. It's used to identify and track everything from parts of an aeroplane to escalator steps on the underground to over 3 million domestic pets in the UK alone. Companies such as BAE Systems, London Underground, Valent Group, and Hoistech are putting this technology to work with great success. Core RFID supports our existing working processes, saving time, reducing costs, and removing errors. RFID is making an important contribution to error reduction and increased efficiency. The Core RFID solution is helping us to streamline operations and deliver a better service. The Core RFID project was completely successful. With these tags, you can capture data where and when it happens, and use that data immediately. To help you do this easily, we've developed our Flow OK software solution. Flow OK automates the collection of data at every step of the process. Use it to monitor the whole end-to-end production process. Use it to tell what stage in the assembly a product has reached. Use it to tell you how many products have been completed. Or use it with Gateway to tell you when goods move from one place to another. Flow OK delivers information across a simple web interface and integrates with industry standard hardware and ERP software, as well as with your own in-house systems. So, for help on selecting the right approach to tracking parts, materials, tools, or work in progress on the...
Alright, so this should give you a general idea of how our RFID actually work, used in the factory level. Alright, for the advantage and disadvantages. The advantages are RFID does not depend on a physical contact or direct line of sight, so if it is used in the factory, it actually won't cause any damage to the product. So that's one of the advantages. And also RFID, a lot of information can be contained compared to traditional technologies. And also in RFID, the data can be read and also rewritten, and also can be altered. So so can be reused multiple times. If you want to use the RFID in factories, actually the cost will be a lot higher than traditional technologies. So here is a general comparison between all these technologies for data capturing, and you can see it's barcode, RFID, and what are the advantages and disadvantages. And when choosing of your technology, it really depends on your own budget, right? And also what is the application? Do you really need really complicated technologies for a very simple data capturing function? Probably not, right? So in that case, you probably should just use a simple barcode to capture everything. And some other IDC technologies will be magnetic stripes. You can see that from credit cards, slide those cards. Also some optical character recognition. We can take a look at this.
We here at Bolton Technology are constantly working to make your life a little bit easier, and we've done that with OCR, Optical Character Recognition. This feature allows the mechanic to simply use their tablet and take a photograph to pull all of the vehicle's information that they'll need, whether it's for service, parts, or just to get a background information on the car.
What's so crazy about OCR? Well, every vehicle has a 17-digit VIN number. It's 17 ways to get it wrong. And then we have the license plate, and sometimes you can't translate what's going on there. OCR reads the exact plate as it is and takes all that play out. It's pretty straightforward. Using Mobile Manager on a tablet, you're going to write up a person, bring them in, okay, and all you have to do is you hit the right buttons here, open up customer, and we have a little camera icon right here, and all I have to do is go like this and take a picture, and there it goes. It decodes the whole thing right for me.
Is this program easy enough that somebody like me who has no car knowledge whatsoever, that I could figure out how to use this?
Absolutely. You know what a camera picture looks like, a picture of a camera, right? Well, come here and let me show you. See that right there? That's your camera picture. So it's really easy to do this. All you have to do is tap on that camera icon, take the tablet, aim it at the license plate, and basically take a picture of the license and give it a moment to digest and hit OK up there. And it's now saving, and voila, there's your VIN number, your license plate number, and there's all the build data just like that.
Currently, OCR is only available for Mitchell users. However, we are working to make it possible.
All right, so that's OCR, and also recently people have developed machine vision technologies. So basically, you just take pictures, or by looking at the general shapes or graphs, you can actually contain the information, read the information. So that's all about the AIDC technologies. So basically, all you need to know is you understand how each of the technology works, and also how they are applied in industry, and also your lives. All right, that's all for today.